Okay, so if you have something in the form ax squared plus bx plus c equals 0, this is quadratic equation and with a different from 0. Because if you have a equals 0, then you have 0x squared plus bx plus c equals 0. And this is the same as bx plus c equals 0. The x squared disappear, so this one is linear. And with linear equation, the number of solution you can have is at most 1. Okay, so this chapter we deal with quadratic equation, which means the highest power of x is 2, so a is different from 0. And for a quadratic equation, you have a formula for discriminant. It is b squared minus 4ac. And there are 3 situations here. First one is your equation. Let me note this. Let's call this equation star. So if the star has 0 solution, then what should the discriminant be? Anyone knows? Yes, it equal to 0. So if the question asks you to determine the coefficient a, b, c such that quadratic equation has 0 solution, it means you have to find a, b, c. Sorry, this one is smaller. It means you have to find a, b, c such that d is less than 0. And if they ask you to find a, b, c such that the equation has one unique solution, it means finding a, b, c such that d equals 0. And if they ask finding a, b, c, so the equation has 2 distinct solutions, it means finding a, b, c such that d greater than 0. One thing students make mistake a lot is finding a, b, c such that the equation has a solution. Has a solution means that have one solution or 2 solution. So in this case, you have to find a, b, c such that d is greater than or equal to 0. Okay, has one solution is when d equals 0. Has 2 solution is when d greater than 0. So has one solution or 2 solution means d is greater than or equal to 0. Does this make sense? Okay, and in the case the equation has 2 distinct solutions, then the solution is in the form minus b plus minus square root of discriminant over 2a. Is this formula true when the equation has one unique solution? Can someone tell me? It is true. Yes, it's true, right? And it's true because when the equation have one unique solution, d equals 0. So this one is square root of 0, which is 0. And something plus minus 0, it is the same. That's why in the case d is 0, the equation only have one solution. Okay, based on what we just discussed, I want you to try with the first question. So we have to find non-negative integer m. Non-negative includes 0. Okay, 0 is also non-negative. So non-negative integer, it means m can be 0, 1, 2, 3, dot dot dot, but not like m cannot be all of, can't be all of them, because it affects the number of solution that this equation might have. So only some of them that can satisfy this condition. So can you try to find n such that this equation here have two distinct solutions? I will give you 3 minutes to think about it. So I take it up at 3:19. I also just launched a poll. In case if you found out the solution, you can vote it. If at 3:19 you don't know the solution, just choose I don't know. Okay, there are 17 people answered. I want to get more answers from you. So maybe 10 more seconds. If you don't know, choose I don't know. Okay, let's see the result. I'm sharing the poll result with you. So majority chose A, which is good sign. Can someone tell me how did you do it? You can type in the chat or you can speak. Yeah, that's true. Use discriminant true. When m equal 1, discriminant greater than 0. That's good. Okay, substitute the values in quadratic equation and see if it produces two solutions. That's good strategy too. Okay. But the last one is only work if I already give you like ABC choices. If you see this question in the test and you don't have the option, then you have to solve it. using discriminant. The first thing I notice is I would never choose this one. This one has to be out immediately because for quadratic equation have two distinct solution. It means the coefficient b for x has to be different from 0. I wrote it here, a different from 0. Okay, so m equals 0 have to be crossed out immediately. And then two distinct solution means discriminant is greater than 0. So I have to find m such that discriminant greater than 0, and discriminant is b squared minus 4ac. B here is minus 5, so minus 5 squared minus 4. A here is m and c here is 4, so is 4m, and it equal to 25 minus 16m. And I want this to be greater than 0. And then let's see. So if you plus 16m to both sides, so plus 16m to both sides, you get 25 is greater than 16m. Okay, and you divided both sides by 16. It doesn't change inequality direction. It doesn't make it to be smaller because 16 is positive. When you multiply or divide by a positive number, inequality direction remain the same. So you have 25 over 16 is greater than m. Okay, and the set of m that we want have to be non-negative like this, but you already cross out, let's use this color. You already cross out 0 because if m is 0, the most number of solution it can have is 1, so 0 is out. And now you see that m has to be smaller. This one is the same as m is smaller than 25 over 16. And this one, if you calculate into number, it will be 1 point something. Okay, so this one is 0, this one is 1, this one is 2. So m has to be in this part, and m can't be 0. M has to be integer. The only solution m can take is 1. So A is the correct answer. Does this make sense? Do you have any question? Okay, if you have any question, you have to ask, okay? Because it might come up in your test. And yeah, if you don't ask, you might not be able to do the test well. Same question, find OA such that this equation here have two distinct solutions. I don't have ABC this time, so I will just give you 3 minutes again, and I take it up at 3:28. If you found out the solution, you can type in the chat too. Did anyone get the answer? It has two distinct solutions for all a greater than 3. I see. What is your discriminant? What did you get for b squared minus 4ac? Good, good, good. Okay, very good. So I see someone got the correct answer. For question asking for like 5 coefficients such that you have 0, 1, or 2 or a solution, the first thing I would do is finding discriminant b squared minus 4ac. Okay, here b is the number in front of x, so it would be 3a plus 3. I square it minus 4. A here is 1, right? Because 1 minus x squared equal x squared. And then c is 2a squared plus 6a. Like this. So if you expand this out, you have 3a squared plus 2 times 3a times 3 plus 3 squared minus 4 times 2 is 8. And then minus 4 times 6 is 24. Okay, so this would be 9a squared plus 2 times 3 is 6 times 3, which is 18a, plus 9 minus 8a squared minus 24a. 9a squared minus 8a squared is a squared. 18a plus 18a minus 24a is equal to minus 6a. and we plus 9. When I see something with a square and a and then a constant, when I see a pattern like this, I think about completing square. Okay, so that's what I think whenever I see like a square, a, and a constant. There might be coefficient in front of them, but that's not a problem. So if I try to bring this in completing square one, like I want to bring it into something like this square and then plus a constant, okay? Then I got a square here and I have 2 times a, and then I want to make it to be 6, right? I think 2 times what equals 6? So 2 times 3 equals 6. I put 3 here and then I have 3 square. Because in the formula a plus b squared, it is a squared plus 2ab plus b squared. So I got a here like this and 2a, so 3 is b. I just plus 3 square in, and it just the same as 9. If in other case it can be 10 or 11, then you can just plus 1 or 2 in, no problem at all. Okay, so this one is equal to a minus 3 square, and the equation has 2 distinct solutions when d is greater than 0, right? Which means when a minus 3 square is greater than 0, I want to ask you for a function fx equal x squared, what is the minimum value it can be? Is from the basic fact, right? It is greater than or equal to 0, right? So the graph will look something like this for fx equal x squared. So think about a minus 3 as a single number x. Then by basic facts, we know a minus 3 square is greater than or equal to 0, right? And we want this to be greater than 0 only. We just don't want it to be equal to 0. We just don't want the point here, right? Okay, let me delete this. Okay, so we don't want a minus 3 squared equals 0. Because if it is not equal 0, it has to be greater than 0. And that's what we want. It means we don't want a such that a minus 3 squared equals 0. And if you square root both sides, it gives you this, which means a minus 3 equals 0. It means a equal 3. So we don't want a equal 3. Therefore, for every a real number, a different from 3, d is greater than 0. Does this make sense? How about everyone else? There are 25 people. How do you remove the absolute sign? Okay, so let's talk about this. If you have absolute value of x equal to 0, it means x equals 0. Why? Because like 0 equal minus 0. Okay, but if you have absolute value of x equal 1, then you can know x equal 1 or x equal minus 1. Why A not equal to 3? Because A minus 3 squared is discriminant. And we want the equation to have two distinct solutions, which means we want discriminant greater than 0, which means we want A minus 3 squared is greater than 0. If A is equal to 3, A minus 3 squared equals 0. And that's not what we want. We want it to be strictly greater than. I'm recording this and I will post the recording on Quarkus. Does it make sense why A not equal to 3? Okay. And does it also make sense how I remove the absolute value? Okay. So let me show you this. Let fx either function of absolute x. Is it because A minus 3 equals 0? Yeah, because absolute value of minus 3 equals 0. It means that A minus 3 equals 0. Because if you look at a graph of absolute value function, like you have minus 1, 1 as x here, 2, minus 2. So absolute value of minus 1 will be 1. Absolute value of 1 will also be 1. Similarly, absolute value of minus 2 equal to absolute value of 2. You see? So absolute value of a number is 0 only when that number is 0. So that's why I know that A minus 3 equals 0. If you know absolute value of a number equals 0, it means that number is 0. But if you have absolute value of x equal 1 or 2, then you can see there are two values of x that can satisfy. See, this point and this point, this point for absolute value equal 1. But for 0, only at one point. Are we good with this? Okay, now I will move on to inequality in AGM, which confused many people. So there are some basic facts that you have to know, and you have to remember. The first one is for every real number a squared will be greater than or equal to 0. You will use this fact many times throughout this course and might be other course as well. And if you have a number a less than or equal to b, and you have a positive number c, then you multiply c to both sides. It doesn't change the inequality direction. I want to ask you, if you have a greater than or equal to b and c is greater than 0, is it true ac is greater than or equal to bc? Is this one true or false? Yep, true. Okay. Because you can just think the A here is in terms of B position, and B here is the A position here. What if I have A greater than or equal to B? I don't know any information about C, and I say AC greater than or equal to BC. It is true or false? Why is it false? Because C is smaller than 0, then inequality flips. Correct. So if you have A greater than or equal to B and C smaller than 0, then AC will be less than or equal to BC. And this one is true. Okay. The third one is you can only take square root of A if and only if A is greater than or equal to 0. You cannot take square root of a negative number like this, like this. So technically, you can take square root of it, but it is not a real number. And we only deal with real number in this course. That's why remember, if a number is being square root, that number has to be greater than or equal to 0. Okay, and I want to ask you, square root of 9 equal plus minus 3. It is true or false? Okay, I see two answer true. Anyone disagree? Okay, one person disagree. Two-person disagree. Good, good, good. Okay, so it might looks right to you because 3 squared equal 9 and negative 3 squared equal 9. This one is true, this one is true. However, this one is false because square root of a number, square root of a number A is always greater than or equal to 0. Square root of something can never be a negative number, okay? So remember this. Many people make mistake at this point. Square root of a number is always non-negative. And if you want negative 3, you have to say it's equal to negative square root of 9. Okay, so next thing is AGM. The first version you can use for any xy real number, which is xy less than or equal to x plus y over 2 square. And why is it true? Because it's similar to saying xy less than or equal to x plus y squared over 4. And if you multiply 4 to both sides, you get this. And if you expand things out on the right hand side, you get x squared plus 2xy plus y squared. And if you minus 4xy on both sides, you get left hand side is 0 and right hand side is 2xy minus 4xy, which gives us negative 2xy. And is equivalent to when I see something like square and then that one without the square, like just to the power of 1, and this one is square again, I think about completing the square. So that's what we have here. And x minus y squared is greater than or equal to 0. This is true by basic fact that we just mentioned. Everything square is greater than or equal to 0. So that's why we get this AGM. Okay, and the second version of AGM is when we square root both sides. So instead of xy, I take square root of xy. I also will take square root of this. what do we have to notice when we take a square root of a number? Greater than 0, right? So if I want to take square root of a, I have to make sure that a is greater than or equal to 0. Okay? So at this step, I know that xy has to be greater than or equal to 0, which means xy has to be both both non-negative or both negative. But then it will only give us these. But the one in the book, it is square root, sorry, is not absolute value, is square root, my bad. So square root of xy is less than or equal to x plus y over 2. So when it is true, when does this inequality hold true? It has to be one of these cases. Yep, when xy is greater than 0, greater than or equal to 0, but then if xy are both negative, like -3 and -5, if you times them together is 15, still greater than or equal to 0. But why does this inequality doesn't hold true for xy smaller than 0? Then left side will be greater than right side. Correct, because when xy is a negative number, then x plus y would be negative, right? If x, y are both negative, then x plus y would be negative. And the left-hand side, square root of a number is always greater than or equal to 0. But this one is negative. So the inequality doesn't hold true when x, y are both negative. Therefore, we only keep the first condition, xy is greater than or equal to 0. Okay? So this one is a second version of AGM that you will use. And this one is a first version. For the first version, you can use it with any xy real number. However, the second version of it, if you want to use, you have to explain why x and y are non-negative. Okay, so based on what we just discussed, I want to guide you through this exercise. There's only 10 minutes left, so I might solve it quick. As I told you, when I see x squared and then x to the power of 1 and a constant, similar pattern, y squared and y to the power of 1, z squared and z to the power of 1 and constant here, I think about completing square. The strategy I would take here is completing the square. And okay, whatever I do here is rock fork. In your proof, it has to be in reverse order. So I will let 2 times xyz being subtracted from both sides. So this one becomes 0. And the left hand side appear minus 2 times x plus y plus z. And then I group x squared with 2x y squared with minus 2y, z squared with minus 2z, and plus 5, which is a constant left here. And then I try to completing the square. So I have x squared minus 2 times x. And I want to keep it as 2 times x because that's what we have above. So I only times 1. And then in order for it to be a square, if you look at the pattern, a minus b squared, it is a square minus 2 times a times b and then plus b squared. You can see x is in the row of a and 1 is in the row of b. So what I'm missing is plus b squared, which is plus 1 squared, which is plus 1. And I would do the same thing to completing square of other. So y squared minus 2 times y times 1 plus 1 and z squared minus 2z times 1 plus 1. I see here plus 1 plus 1 plus 1, which is plus 3. And here we have plus 5. So we only need plus 2 left in order for this whole thing be equal to the left-hand side. And everything will be greater than or equal to 0. So this one, we completing it as a square. So it would be x minus 1 square, y minus 1 square, z minus 1 square, plus 2 greater than or equal to 0. And then, firstly, we want to prove this inequality is true. And this inequality is the same as this inequality, which means we have to prove this inequality is true. So why is it true? Can we use some basic fact? So we recall basic fact. By basic fact, any number square is greater than or equal to 0. So x minus 1 square is just a real number and you square it, right? So it's greater than or equal to 0. Similarly with y minus 1 square and z minus 1 square. Okay. And then if you plus them together, you also have 2 is greater than or equal to 0. This inequality is true as well because this side is interpreted as greater than or equal to. So if you plus everything together, you will see that the sum of them is greater than or equal to 0. Because there is property like this, a greater than or equal to b, c greater than or equal to d, then a plus c is greater than or equal to b plus d. So that's why if you plus everything on the left-hand side together, you will get it greater than or equal to 0 plus 0 plus 0 plus 0, which is 0. But can we use both sides of inequality to prove? Shouldn't we reach right-hand side from left-hand side? What do you mean by can we use both sides of inequality to prove? Like, do you mean we can't use like both of them here? You can, and this one is rough work, so your formal proof would be starting by this. By basic fact, you got these, and then you plus them together, you will get these, and you will work all the way up until you reach these. So you don't have to just stick with one side. So the proof would be from these and going backward. From a proof always working backward or rough work. It's not always, but it's usually be, because in our rough work, if you are starting with what you are supposed to prove, if you start with this is what you are supposed to prove, right? And you start with it, then it is not a formal proof. But if your rough work, somehow you can come up with this first and work all the ways back, then your rough work can be used as formal proof. Okay. Any other question, or should I move to the next one? Okay. So for this one, it's supposed to be a poll, but I know we're running out of time. I want to talk about when you see something like this, like similar term, but one is in denominator and one is in numerator. You can think of x squared as x squared over 1 like this. You think one is in numerator, one is in denominator. You would think about if you multiply them together, you can cancel them. And luckily our AGM, it is x plus y over 2 greater than or equal to square root of x times y. So it is a relationship between product of two number and the sum of two number. So here they want you to find the minimum, which means they want you to find a such that the expression is greater than or equal to a, right? Because it is minimum, so you want to find something greater than or equal to a number. If they ask you to find maximum, it means they want this expression less than or equal to a number, then that number can be the maximum. But the minimum, we want something with greater than or equal to, like this. And I would think if I multiply them together, these will be canceled out and I just leave with a constant. So I think if I let this as let me change to A and B here to avoid confusion. A plus B and AB here. And remember, this version of AGM, if you want to use, you have to check that A is greater than or equal to 0, B is greater than or equal to 0 if you want to use this version, okay? I would try to let this one as A and this fraction as B, then it will be greater than or equal to, instead of 2 under denominator here, I would multiply it to this side. So I would have 2 square root of A times B. So A times B. Okay. So this sum is greater than or equal to this term, and I still keep the 4. Okay. And as I said, if you multiply them, these x cancel out, and you are left with square root of 36, which is 2 times 6 plus 4, which is 12 plus 4 equal 16. Okay. And before you apply these, you have to argue x squared is greater than or equal to 0 by basic fact. And then x squared is greater than or equal to 0 also by basic fact. 30 is a positive number, so positive number divided by positive number is a positive number. Okay, so that's why we can apply this AGM. So here, before applying, explain x squared greater than or equal to 0 by basic fact, and this one also greater than or equal to 0 because positive number over positive number is a positive number. Okay. Is there any question about applying AGM here? Okay, good. And then they ask us about the minimum. So I know it's overtime, you can leave if you want, but I still want to cover the rest. So if you have like the expression greater than or equal to 16, then 16 is minimum. If and only if you can prove the expression can achieve 16. Why? Because, for example, you have 3 friends. The first one is 20 years old, second one is 19 years old, and third one is 18 years old. You can say that the age of your friend is so you have 3 friends, 20, 19, and 18 years old. You can say the age of your friends is greater than or equal to 18, but you can also say the age of your friend is greater than or equal to 12, right? Both is correct. However, 12 is not the minimum age in the group of your friend because no one here has age 12. However, 18 is a minimum because there is someone who is 18 years old. So the point here I want to make is that for question asking finding minimum or maximum, you have to find x such that AGM equality holds true. Okay? Which means I have to find x such that A equal B. It means find x such that A here is x squared and B here is 36 over x squared. So if you multiply x squared to both sides, you have x to the power of 4th equal 36. And then if you square root both sides, you have x squared equals 6, which means absolute value of x equals square root of 6, which means x is plus minus square root of 6. However, here we say x is greater than 0. X is greater than 0. So x is square root of 6. So equality happen when x equals square root of 6. And that proof 16 is a minimum of the expression here. Does this make sense? Okay. How do you get x squared equal 36 over x squared again? Okay, so I have to find, in order to prove 16 is minimum of the expression, I have to find x such that AGM equality holds true. And then it means find x such that a equal b. A here is x squared. B here is 36 over x squared. That's why I have to find x such that x squared equal 36 over x squared. Okay. Okay. So that is the last question for today. Do you have any question for me? I will start recording.